In this video, we're going to do another constrained resources example, except we're going to use the solver tool to actually complete the problem. And so the solver tool allows us just to do a lot more complex constraints. And so we can have multiple constraints and give all of those constraints to Excel and then ask Excel to optimize profit for us. And so that's just a really great tool that allows us to do it faster and at a more complex level. But also, besides that, it allows us to just easily change considerations inside of our template and then resolve it and get the information instantly. So I think it's a really great tool, and I hope that you remember this for when you go to industry, or at least just remember that it exists. So the thing about Solver is that it's not automatically enabled inside of Excel. You have to add it as an add-in. So I'm going to show you how to do that. I'm on a Mac right now, so I'll show you on a Mac, but then I'll also provide a link with this video that is somebody else's YouTube video on how to enable it on a Windows so that you can do that if you don't have a Mac. So what you can see from my data tab is that I have this solver button in the right-hand corner. You most likely do not have that unless you've already added it as an add-in before. On a Mac, you will go to Tools and then Excel add-ins, and then you need to select the solver add-in and press OK. If you're on a Windows, you will go to File and then Options, Excel add-ins, and then you will find the solver, and then there's a little place where you're going to say Go, and then when you do that, it's going to open a new menu, and you'll select the solver and press OK. But like I said, I'm going to share another video where somebody else walks through that so that you can actually see it for yourself. Once you've enabled it, you will then see the solver tool inside of your data ribbon. So now let's look at how this actually works. So what we have in this situation is that we actually have 3 constraints rather than just one like we did in the previous example. We have only so many machine hours available, we have only so much labor time available, and there's also a maximum demand for each product. Our Pikes Peak Manufacturing produces 4 products, the Alpine, Boulder, Canyon, and Denver products, and they want to maximize contribution margin given our constraints. So what we see down here as far as our product data is that we have selling price and variable cost per unit, which is then subtracted to give us contribution margin per unit. We also have our constraints listed. So we know that it takes 2 hours of machine time for the Alpine versus 3 for Boulder, 2.5 for Canyon, 4 for Denver. Then we also have the constraints of time required as far as labor hours goes for each product. And then finally, we know that there is a maximum demand that our customer base is willing to purchase from us. Below that, we see our constraints. So these are our available resources, and for machine hours, we have only 3,000 hours available, and we have 2,000 labor hours available for the month. We are going to tell Excel that we want it to use the solver tool to optimize our contribution margin, which is down here in B44, by determining how many units we should produce of each of our 4 products. So these are going to be the solver tools or cells that solver is going to change, but down below, the whole template is set up with formulas to help Excel see how to calculate that. So the contribution margin is formatted as a formula saying the contribution margin per unit times the quantity that we're going to produce plus the next product plus the next product plus the next product. Currently that is 0 because we have no units to produce. But if we changed that to 500 units of Alpine, we can see it's updating contribution margin. It's important that these formulas are set up correctly because that is how Excel is going to work backwards to solve the problem. So if you don't have your formulas set up into the template, then obviously it can't solve anything for us. Then below, we have all of the constraints that we need Excel to consider when it is optimizing contribution margin. So we have machine hours used, and what it says here is currently 0 hours. The formula that is being performed is the number of units produced by the number of hours required for that unit plus the next product plus the next product plus the next product. So that is going to calculate total machine hours used. We have to tell Excel that whatever combination of products it makes, it cannot exceed 3,000 hours. So our first constraint is that the number of hours used must be less than 3,000. The second constraint is labor hours. Same thing happening here where the formula is the number of units times the labor hours required for that unit plus the next product, next product, next product. And we're going to tell Excel whatever combination of units that it comes up with to maximize profit, it cannot exceed 2,000 labor hours. Then we have some additional constraints here. As far as demand, we never want Excel to produce more than 750 of Alpine because that's our maximum capacity that people are willing to purchase. And I actually just saw I have a mistake here. This should be 500. I think I might have changed that in an example in live class so that we could see the impact of it, so I apologize. Okay, so now we have it can never produce more than 500 Alpine, don't ever produce more than 400 Boulder, never produce more than 600 Canyon, never produce more than 300 Denver. And the formulas here are just referencing up to the cells that Excel is going to change, the number of units it's going to produce. There's actually 2 more constraints that we need to consider. One of which is that we are going to have to tell Excel that none of these values can be less than 0. That seems obvious, but Excel is not a human. So we have to tell it, don't optimize it by making one of these a negative number. That's not how production actually works. The other thing that we have to tell it, which I gave you down here further in the directions, is that we want this to be an integer. So the other constraint is that all of these units to produce must be integers, meaning whole numbers. And that is because obviously we cannot produce a partial unit or sell a partial unit. So we want it to optimize contribution margin only using whole numbers. So that is what we are going to set up inside of the solver tool. And having it laid out like this is not 100% necessary because we're going to input it into the solver. But I think it's really helpful for you to understand, like as you're kind of like thinking through and building out your template, what it is that you're going to put in solver, and also helpful if you're going to come add or change constraints later, or if you have like somebody else that you're working on this project or this Excel sheet together, you don't want them to have no idea what sort of constraints you set up. So this is just kind of a best practice so that everyone is aware of what solver is doing. So now we're actually going to do it. So I'm going to select total contribution margin because that's what I want to optimize. And I'm going to hit solver. And this solver menu pops up. And so it's saying, what is our objective? And our objective is that we want to maximize, so we have max already selected, cell B44. And so apparently it jumped over to F44 when I clicked solver, so I just clicked back on B44. So it is going to maximize that cell. Next, it's saying, what cells should I change? Where are your variable cells located? So I clicked into that location, and I'm going to select cells B39 over to E39. So now we've told Excel, maximize the contribution margin by changing how many units we are going to produce. Next, we need to tell it what constraints exist, which we already kind of laid out down here. So if we come into the constraints, we can say add, and we can now start telling Excel what these constraints are. So the number of machine hours must be less than or equal to the constraint of 3,000 hours. We'll say add, and then we can do the next one. The labor hours must be less than or equal to our constraint of 2,000 hours. Add again. The number of Alpine produced must be less than or equal to 500. So right now, we're really just doing a whole bunch of clicking, recreating and telling Excel these constraints that we've already laid out. So we'll continue this the whole way down. Okay. Now we also have this production quantities must be greater than 0. So I'm going to come back up and I'm going to select cells B39 through E39. This is our production. I'm going to change this drop down to greater than or equal to 0. And I'm going to add that constraint. And then finally, we have the constraint that we want these to all be whole numbers. So I'm going to again select our production variables. And here in the drop-down menu, I'm going to select int, which means integer, and I'm going to add that. And then we should have hit OK, not add, because then it thinks you're trying to add an empty one. So if you hit cancel, it'll bring you back to this menu. And so now we can see each of those constraints that we had already talked about and aligned here in our Excel spreadsheet. If you had a mistake, you can change or delete any of these constraints at any time. We have this make unconstrained variables non-negative. We'll leave that checked. We're going to change selecting a solver method and change that to simplex. And then we're also going to go into options. And in yours, under all methods, if you have solving with integer constraints, sometimes this gets checked just like as a default, but we don't want it to ignore integer constraints. We do want it to follow that constraint we said. So you need to make sure that this is unchecked. Then we'll say okay. And so now we have our solver ready, and we can tell it to solve. When you click solve, it's going to pop up this menu saying that it has solved the problem for us. Do we want to return the solver parameter? So do we want it to go back to 0? Do we want it to save this? Do we just want to press OK? I'm going to press OK and scroll back up so that you can see that it filled in for us that we should produce 500 Alpine, 160 Boulder, and 600 Canyon, and that's going to give us a contribution margin of 83,620. As I mentioned earlier, part of what is so cool is that we can change the information or the constraints inside of this and then just hit solver and run it again. So let's just say, I actually think I gave you some examples to play with down at the very bottom. What if machine hours increased to $3,500? How much more profit could we make? And so if we come back up, we can change the constraint of machine hours to 3,500 and then go back to solver, hit solve, and then say okay. And now we see that it has changed our capacity and our contribution margin jumped up to 94,750. And then you can continue just to play around with this. So go ahead and change, like what if labor hours increases? What if the contribution margin for one of the products increases? Go ahead and change these numbers and run solver again to see what happens. You can also, if you just want to keep playing with it, you could say, what if our capacity of Alpine was actually 900 units? We found out there's more demand for that product than we realized. And then run the solver, hit solve, we'll hit OK. And if that's the case, then we can see the best option is actually to prioritize alpine. And so we're going to produce a lot less of the boulder product than we were previously. So go ahead and play around with this, and hopefully you can see how cool it is and all the opportunities that exist.